If you find a USB stick on the ground, would you plug it in just to see what's on it? Most people think a USB stick is just for storage, harmless. But what if I told you that a USB stick can act like a human hacker, that it can take over your computer in seconds and you would never even know? In this video, I will show you how one of these tiny devices can bypass your passwords, steal your data, and why even cybersecurity experts can get fooled by them. This right here is called a Rubber Ducky. It looks like a regular flash drive, but it's not. It's actually a programmable USB attack tool. When you plug this into a computer, it doesn't behave like a storage device. Instead, it acts like a keyboard, and that's the whole trick. When you plug it in, your computer thinks it's just a keyboard, and that's gotta be safe. And your computer listens because generally keyboards are trusted. It doesn't trigger antivirus, Windows Defender, or any typical security software, because from the system's perspective, it's just a human typing. But in milliseconds, this thing can type out commands faster than any human ever could, opening terminals, installing malware, downloading your files, you name it. There are many types of malicious USBs, and some of them include the Rubber Ducky from Hack5, do-it-yourself versions built using Arduino boards, Raspberry Pi Pico-based ones, and even tiny devices like the DigiSpark. The Hack5 Rubber Ducky uses a custom scripting language called DuckyScript. It's made to be easy. You write a few lines, load them onto the Ducky, and just like that, you have a weaponized USB stick. Let me show you how this thing actually works, because once you see it in action, you'll never look at USB sticks the same way again. Now we're going to write some real scripts and generate the payloads using Payload Studio, and then load them onto the Rubber Ducky by simply dragging and dropping. And this right here is called Payload Studio, which is basically a web-based tool built by Hack5 that makes writing Ducky scripts super simple. You can think of this as a code editor, but specifically for USB attacks. So let's start with something fun. This one doesn't steal data or open backdoors, but it just spams Notepad with a message. The point here is to show you how quickly and easily a Rubber Ducky can automate keystrokes. And you will notice that usually we start our payload with a short delay. In this case, the line delay 2000 gives the computer 2 seconds to fully recognize the device before it starts typing. This is a basic safety buffer to make sure nothing gets skipped. And any line that starts with the keyword rem is just a comment. Now they don't actually do anything, they're just there to make the script easier to understand. And then you'll see that we have a line that says GUI followed by R. This simply tells the Ducky to press the Windows key followed by the letter R, which opens the run dialog on your system. And then it types the word notepad into that run box and then hits enter and waits about 800 milliseconds to let the application open. Everything here just mimics what a human might do, except it's all happening automatically. Now in this next section, you see that one by one, the script types out the phrase subscribe to inject 5 times and then pressing enter after each one so that they appear on a new line. Once the script is ready, we can generate the payload by clicking this button, which will save it as a bin file, which is simply a binary file, and then all you have to do is to copy that binary file onto your Rubber Ducky. And just like that, your USB stick is now a dangerous hacking device. Now if you plug this into a computer, this specific payload would look something like this. You might think, well, it's just a simple script that types out a bunch of words in Notepad, so what's the harm in that? But the thing is, that harmless script could just as easily be changed to download ransomware, steal your passwords, or even open a backdoor that gives attackers full control over your PC. For example, if we take things a step further, we can craft a different payload. Now with this payload, I'm going to show you something more dangerous. This is called a reverse shell, and it can give an attacker remote access to your system in seconds. Keep in mind that all of these examples run inside a lab environment on my own virtual machines, and it's purely for educational purposes only. So do not attempt this on any systems you do not own. Now here, just like before, we use the delay keyword to pause between actions, then open the run dialog box, but this time we run PowerShell as administrator with the line you see here. Now this command would prompt the user for UAC permission to allow the program to make changes to the system. And UAC is basically that pop-up pop-up window that prompts you every time if you're sure you want to continue. And basically, after waiting for that prompt to appear, the script sends Alt-Y to automatically accept that prompt. This line simply disables Windows Defender's real-time protection. It would basically help avoid detection by the built-in antivirus in Windows, and then what you see is basically we press enter and then wait a second in between. This one-liner here is basically a full PowerShell reverse shell. The line looks like it's opening a PowerShell window in hidden mode and then uses a bunch of gibberish after the encoded command flag. Now that gibberish looking part is simply encoded in base 64, and a lot of the times encoding is used by attackers to hide their commands, which makes them harder to detect or analyze. And underneath all that gibberish, if we decode it, what we actually have looks like this. Now this may look fairly complex, but basically how this works is that when the victim's machine runs the reverse shell, which happens when they plug the USB stick, it first connects out to the attacker's system. And in this case, that would be the IP address 192.168.56.103 and using the port number 2121. This means that when the victim plugs in the device, it creates a new object that attempts to connect to the attacker, and then it opens a network stream and continuously reads incoming commands. And when the commands arrive, it executes them on the victim machine and sends the output back to the attacker. But of course, before all this can happen, the attacker needs to be listening for the connection on the other end. Notice that we have the port number 2121 is specified here. This means the attacker is likely listening on this port for incoming connections from any machine trying to establish a reverse shell. Alright, now that we understand what this is all about, let's generate the payload, download it, and then paste it into our Rubber Ducky device one more time. And in this example, I will have a Kali virtual machine listening for incoming connections on the same port number specified in our payload, which was port 2121. So when we plug the Rubber Ducky into the victim's machine, after a few seconds, we would see that it will start doing its magic. And then all of a sudden, we would see that a connection has been established on the Kali VM. This means the attacker has just gained reverse shell access, which allows them to execute code without the user even realizing it. All of this happens very quickly, so the user often can't even understand what's happening. And to demonstrate our connection, we can create a test file on the C drive by running a command from the Kali command line, and then after executing the command on Kali, you'll see the file appear on the C drive on the victim machine. So there you have it, a tiny USB stick, something you would probably just ignore on the street, or in some cases get curious about it and plug it into your device. The purpose of this video was to show you that USB sticks can be way more dangerous than they look, whether it's opening Notepad as a prank, silently downloading files, or even launching a reverse shell to give an attacker full control over your system. These tools are not a joke, and the scary part is that your computer never even sees it as a threat. It simply believes that it's just a keyboard. This is why social engineering is always so effective, because it exploits trust and not tech. And it's also why even trained professionals have already fallen and will continue to fall for these tricks in the future, because it only takes one mistake to lose control of your system, and awareness is everything. As always, thanks for watching, and I'll see you in the next one.